Well, right now, somewhere in the world, an engineer is making a decision that would determine whether a system works reliably for 20 years or fails catastrophically in year 3. That decision is a RAMS decision, and most engineers making it have never been formally taught what RAMS actually is. I'm Zach, and this channel is about changing that. In this first video, we're going back to the basics: what RAMS engineering is, where it came from, why it matters, and how it connects to almost every engineering discipline you can think of. RAMS stands for reliability, availability, maintainability, and safety. 4 words, 4 disciplines, and together they form the backbone of how we engineer systems that are not just functional, but dependable. You've almost certainly encountered all 4 of these concepts before, maybe under different names, maybe buried inside another standard methodology. But RAMS is the discipline that brings them together, treats them as interconnected, and asks the question: how do we engineer a system that performs its required function for its required duration in a safe and cost-effective way? Let me break each one down briefly, then we'll zoom out and look at the big picture. Reliability is the probability that a system or component would perform its required function under stated conditions for a specified period of time. Think of it like this: if you start a car engine 1000 times, how many times does it start successfully? That ratio, measured over time and across conditions, is reliability. The key metrics here are MTBF, mean time between failures, and failure rate as well, that famous Greek letter lambda. We'll dedicate a full video to these, but for now, reliability tells you how likely your system is to keep running. Availability is the proportion of time a system is in a functioning state. It takes into account not just failures, but how quickly you recover from them. A system can be highly reliable, it fails rarely, but have low availability if, when it does fail, it takes weeks to repair. So the classic formula is availability equals the MTBF divided by the MTBF plus the mean time to repair. Maintainability is the ease and speed with which a system can be restored to operational status after a failure, or maintained to prevent one from beginning. This is the discipline that asks, can we actually fix this when it breaks? Are spare parts available? Can a technician access the components without dismantling the entire system? And is the maintenance task documented and communicated clearly? Bad maintainability is one of the most expensive hidden costs in engineering, so you often don't see it until year 10 of a system's life. Then safety. This is the assurance that a system does not lead to a state that causes unacceptable harm to people, property, or environment. Safety in RAMS is not about zero risk. No system is zero risk. It's about understanding hazards, quantifying risks, and reducing it to an acceptable level through design, procedures, and barriers. This is where standards like the IEC 61508 for functional safety for EEPE systems and the EN 5126 for rolling stocks, for instance, come in. So we'll cover all these in depth later in the channel. Now, why it matters. RAMS engineering is not a niche discipline. It applies across virtually every safety critical and high availability industry. So for rail, we have the EN 5126 that governs RAMS across the entire railway's life cycle, from concept to decommissioning. In aerospace and defense, we use the Military Handbook 217F, for instance, to predict the failure rate of components under different conditions. Nuclear, where availability and safety are existential concerns, not just KPIs that we log. Oil and gas, that considers process safety, functional safety, and a famous SIL assessment, the Safety Integrity Level assessment. And then for medical devices, we have the IEC 62304, the ISO 14971, where maintainability can literally save lives. A medical component or a medical device that is not well maintained and is not available when we need it could literally mean the difference between death and life. Power and energy and infrastructure, where we need to keep the lights on, that's where we consider the grid reliability, for instance. We do some asset management, of course, and we consider life cycle cost. So what's common across all of these is that the cost of getting it wrong is catastrophic, financially, for reputation of the organizations, and a worst case in human lives. And yet RAMS is still one of the least standardized, least formally taught disciplines in engineering education. Most engineers learn it on the job, through trial and error or not at all. Let me address 3 things I hear a lot from engineers new to RAMS. First, just say RAMS is just a quality by another name. But no, quality management is about conformance to requirements. RAMS is about predicting and controlling behavior over time under stress in the field. So they overlap, of course, but they are not the same. And then you have safety and reliability are the same thing. And also no, a system can be highly reliable and unsafe if its reliability performs a dangerous function, if its inherited function is not safe by design. And a system also can be safe but unavailable. A safe mode that shuts down, for instance, the whole plant is safe, of course, but not useful. So these disciplines interact, but they are distinct. And finally, RAMS analysis happens at the end of the project. No, of course no. This one is the most dangerous misconception of all. RAMS analysis that starts at the commissioning is not RAMS analysis. It is a post-hoc justification. So real RAMS work starts at concept, feeds into design, and continues through the entire life cycle. So that's the foundation: reliability, availability, maintainability, and safety. 4 interconnected disciplines that determine whether a system earns trust over time. So this channel is going to go deep on all of it, from the fundamentals right through to the specific standards, worked examples, and kind of practical knowledge that usually only comes from years in the field. If you work in RAMS or you're learning it, drop a comment. Tell me what you're working on and what you're struggling with, or what you'd like me to cover. This channel is being built for this community, and that starts with hearing from you. See you in the next one.